I'm Lee Teschler, Executive Editor of Design World magazine. Coupled inductors are basically two separate inductors wound in the same core. A coupled inductor typically comes in a package with the same length and width as that of a single inductor and the same inductance value, only slightly taller. A coupled inductor also typically costs less than two single inductors. The windings of the coupled inductor can be connected in series, in parallel, or as a transformer. Most coupled inductors have the same number of turns, in other words, a 1-to-1 turns ratio, but some now have a higher turns ratio. The coupling coefficient, usually called K, of coupled inductors also has been approaching those of transformers in recent years, about 0.99. The current specifications for a coupled inductor differ depending on whether its windings are physically connected in series or in parallel. So when the windings are in series, the equivalent inductance is more than twice the rated inductance due to the mutual inductance. The saturation and RMS current ratings generally apply to the current flowing simultaneously through both windings, unless otherwise stated in the datasheet. You'll often see coupled inductors used in switching power supplies, and especially in one known as a DC-DC single-ended primary inductance converter, or SEPIC. It's used when you need a converter capable of giving you an output voltage greater than, less than, or equal to the voltage at its input. Wall warts, for example, are often SEPIC technologies. One reason you find coupled inductors used in SEPICs is that they help reduce the size of the converter. And that's important when you're trying to get the power supply to be as small as possible. A rule of thumb is that the footprint of a power supply using two inductors can shrink by a third, simply by using a coupled inductor instead. Besides letting you go to a smaller size, use of a 1-to-1 coupled inductor in a SEPIC makes the circuit design a little easier because it can force the inductor ripple current to split between the two windings. So you can use half the inductance that you'd otherwise need if there were two single inductors in there. And compared to two single inductors at twice the inductance value, the coupled inductor has lower DC resistance, which helps increase the overall efficiency of the converter. For more videos, go to powerelectronictips.com and designworldonline.com.